All right, welcome to this lesson on maximum and minimum word problems. This is really taking quadratic equations and bringing everything together. So we're, for the first time, kind of bringing it together and putting it to some sort of useful sense and kind of showing you how these kind of equations, quadratic equations, can be used to solve different types of problems that might exist, okay? Now, since quadratics are parabolas, which means they are either U-shaped, in other words, if you remember, if I just flick my pen on and I write here over on the side, I know it'll disappear, but they're U-shaped like this, then they have a low point, which we refer to as a minimum, or, and it disappears nicely there, I can go to a N-shaped kind of shape like this, and then they have what's referred to as a maximum. And this is the kind of things that we're most interested with respect to parabolas. Where are they minimized and where are they minimum or where are they a maximum value? And those things occur depending, change maximum or minimum depending on that value of a, that letter or the value of the number in front of the x squared or at the very beginning of the equation. And if that number at the beginning of the equation is a positive number, so we call that a is positive, then it will open like this, okay, and it'll have a minimum value, okay? Whereas if, in fact, the parabola has a negative right in the very front of it, like this, goes like that, then it will have a maximum value or a high point, okay? And there's a few different types of equations that will, or word problems that we'll look at. And I'll go through those different types with you and give you examples. And all of the questions that you will receive will follow those same formats, the same basic structure. Okay. Now, before we begin doing actual word problems, I like to show my students some things so that they understand it a little bit better. So when is it a maximum and when is it a minimum and how does it occur? Okay, so if I take a really weird looking equation like this, for example, okay, and we don't really need to do much. This is in vertex form, so it's not in standard form, so it's in vertex form, and so that allows us the wonderful opportunity to just simply grab the vertex out of it. So as you recall, this is the x value of the vertex, and it is going to be positive, okay? So in this particular case, it's going to be 56. We change the sign from negative to positive. And the y value of the vertex is just the number on the back. And so in this particular case, 920, okay? Now, since this equation is a positive, that tells us whether it will be a maximum or a minimum. So in questions like this, you have to circle, is it maximum or is it a minimum? Well, when it is positive out front, I don't care, that's a very tiny number, but it is still positive. It is still greater than zero, okay? 0.00006 is a very tiny number, and it changes the shape of the parabola. It means that the parabola will open like this, but it'll be really flat. Oh, apologize, for some reason it wants to jump on me again. It will be really flat. It'll kind of go like this, okay? And it'll have a low point. So that means this is going to be a minimum. And it's going to be a minimum value of the y value of the vertex, okay? And the y value of the vertex is 920. So it's going to be minimum of 920, and that will occur when x equals 56. So we usually say when x equals 56. And this is very common practice, okay? So the minimum is 920 and it occurs when x equals 56, okay? We can go to the next question and say, well, oh, here's minus 6. And, oh, well, first we can do the vertex. So the vertex will be minus 7, okay, and minus 21, okay? Minus 7 and minus 21. And so in this particular case, we can say that this time it will, because it's negative, it's going to open like that, and it's going to have a maximum value. And in this case, the maximum value, I said 21, didn't write the 1 there, is going to be minus 21. So we say maximum minus 21. And it occurs when x equals minus 7. So we're grabbing all this information just by looking at the equation. We don't have to do anything fancy. We just have to interpret what the equation is telling us. So the minus tells us that it's going to open upside down, so therefore it's a maximum. We can get the vertex minus 7 and minus 21. Maximum occurs, it's always the y value of the intercept, which is minus 21, and it occurs when x equals minus 7. All right. Now we can go to other kinds of questions where we have to do a little bit more work as well. And this is where it gets a little trickier. Okay. And we have to use our factoring tools that we used before, our factoring skills to be able to find the vertex. So in this particular case, we're going to factor this because it is in standard form. Remember, it has an x squared and an x term. So therefore, I can't use just like my standard grab the equation right out of the grab the vertex, sorry, out of the equation by looking at it. I have to factor it. And so in this case, this one factors of 60 that add to minus 16 are x minus 10 and x minus 6. Sorry, not 8, 6. Okay, and then we can find the roots. Okay, and our roots in this case are 6 and 10, so positive 6 and positive 10. And my vertex is going to equal, I can already see the first half of the vertex is going to be 8. It's going to be 8 comma, and I don't know what the y value of the vertex is. How do I get 8? Well, I'm pretty good. I can see that halfway between 6 and 10 is 8. Or I can add 6 and 10 together, get 16, divide by 2, that gives me 8. If I want. Either way, you know, you can work that out in your head. But if the roots are 6 and 10, then halfway between them is what I'm looking for. Now, to find the y value of the vertex, I simply substitute in these values here. So I'm going to go y squared equals 8 squared minus 16 times 8 plus 60. Okay, and I'm going to have to get maybe my calculator out to do this. Oops, why it jumps on me, I don't always know, but it does. Okay, so 64 minus 8 times 16, which I believe is 128. Okay, if you don't believe me, grab your calculator, plus 60. And so if we do that, I might want to grab my calculator just to make sure 100% on this. Of course, in this particular program, I have or on my computer, I have a calculator app, so I can pull it up. And I can even pull it to the side here so it doesn't block my screen completely. So 64 minus 128 plus 60. And I believe the answer comes out to be 4, minus 4. Okay, so y equals minus 4. And I can then put in my vertex of minus 4. I see that the value in front of the x is positive, so that means it goes like this. So now I can answer all of my questions here. First of all, I can write in 8 and minus 4. And I can say, because it opens like this, it opens down, this is a low point, that's going to be a minimum of minus 4, and it occurs when x equals 8. And I'm basically done. Now, of course, I can add another level of complexity to some of these questions, right? As I clean up some of the mess here. And I can make it even more difficult where I now have a number out in front of my 14, okay? And so I'm just showing you some examples that are maybe a little bit more challenging, okay? So I can go like this. I can go, to get rid of the minus 14, I have to factor it out front. And so this divides by minus 14. This is going to divide by minus 14, and this is going to divide by minus 14. And so I'm going to write minus 14 bracket, and well, that's going to give me x squared plus 2x, because the 28 divided by 14 is 2. Minus and a minus is going to be positive. Now, I'm not sure what 336 divided by minus 14 is in my head, so I'll bring my calculator back out again. I'll clear it, and I'll say 336 divided by minus 14. Need to put a plus minus in front of that, equals, and the answer is minus 24, okay? So minus 24. Oh, why does it do that? Just doesn't like me sometimes. There we go, minus 24, okay? And now I can factor this quadratic equation here. I still leave my minus 14 out front, and I end up with two numbers that multiply to minus 24 and add to 2. And if you're, without getting into a lot of detail, that's going to be 6 and 4, okay? It's going to be positive 6 minus 4. So it's x plus 6 times x minus 4. And that allows me now to determine my roots. I can quickly grab my roots. I'm just going to clean my page up again here. And I can see my roots are going to be 4, positive 4, because that's the way that'll make that 0, and minus 6. So I have 4 and minus 6. And the vertex now, my x value of my vertex, I can start doing that, is going to be halfway between these two. And remember, that's just adding these two together. So 4 and minus 6 added together is going to be minus 2 divided by 2. So it's going to be minus 1. Okay. And you can count that out on a number line if you want. You can do it in a variety of different ways. And now I'm going to take my minus 1 and I'm going to put it into my equation and see how this all works out. So I get y equals minus 14 times minus 1 squared, which is going to be positive 1 in the end, minus 28 times minus 1, and then it's plus 336. So I might need my calculator again to do some of this math, right? I'm just going to simplify it a little bit. So this minus 1 squared becomes positive 1, so that still says minus 14. This becomes plus 28, and then in the end, it's plus 336. And I think actually I can do this in my head, because minus 14 and 28 are going to give me 14 in total. Okay, so 28, basically take away 14 is going to leave me with 14. And then I'm going to add 14 here. So that's going to be 4 added on to that. It's going to be a 0, right? And 1 added 150. So this is going to work out to 350. And so that is going to be my y value here. Y equals 350. If you don't believe me, grab your calculator again and go through that. I did it in my head. I have a little bit better math skills with respect to that. So now I can fill in my line here. First of all, I can put in my vertex, which is minus 1 and 350. Okay, and then I can ask myself, is this a maximum or a minimum question? Well, it's negative. So if it's negative, that means it's going to open upside down like this, which means I'm going to have a maximum value. My maximum value is going to be the y value of my vertex. So it's going to be 350, and it's going to occur when x equals minus 1. Wow. So rather complicated question, actually. It looks like it might be quite simple, but there's a lot of stuff, a lot of steps you have to do. You have to be able to find the vertex, which takes some time and effort, factor out the minus 14, factor the trinomial, many multiple steps that we've all worked on previously in this class, but we're bringing it all together to sort of do this maximum and minimum stuff, okay? Now, next up, we're going to actually do some word problems, okay? So, and with word problems, it always gets a little bit trickier, but we want to find, there's three types of word problems, and I promise that any questions I ask you on a test will stick to these three types. Of course, there's way more types we could make, but I got to kind of be reasonable about what I do, and so I'll take three types of questions. One will be a maximum product question. So if I take two numbers and multiply them together, what would be the maximum number that they would get? And usually they will add up to a specific number. So in this case, I chose the number 20. So I'm going to say, let x be one number. Okay? Let x be one number. And if that's the case, if they have to add to 20, let's say I gave you a number 7, and what would the other number be if I was going to add, and they had to add to 20? So one number 7, and I needed another number that was going to add to 20. You probably would come up with the answer 13, because 7 plus 13 equals 20. Well, how do you do that? Well, you actually do that by saying 20 minus 7. And if that's the case, we can use that idea to find or state the other number. So you say then, you don't say let, you say then 20 minus x is the other number, okay? So you have to make those statements. Now, maximum product refers to multiplying, right? And so what we're going to do is we're going to say let y be the product, okay? So let y be the product. And therefore, we say y equals x times 20 minus x. Okay? Now, we're not going to actually multiply them together. We're going to try to find the vertex of this equation. Now, we can multiply them together if we want, all right? Just for interest's sake, because what ends up happening here is y equals, if we multiply them together, y equals 20x minus x times x, which is x squared. And if we rewrote that, it would be minus x squared plus 20x, and that would be the proper way to write it. And it's important to do that because we can see that by having a negative out in front, we are going to have a parabola that would open upside down and give us a maximum. And remember, we're looking for a maximum product. Most of these questions actually look for maximums because, yeah, we're not really as interested in minimum values as we are in maximum values, okay? But if I go back to this equation right here, I can see the roots right away from here. And the roots of this equation are going to be when this is 0 or when this is 0. So when do they become 0? Well, they become 0 when x is either 0 or x is going to be 20 minus what would give me 0? 20. Okay, and for a lot of students, that's I don't know, that's not something that is really obvious to them, but this is basically when is x equals 0 and when is x equals 0 for this. And in either case, the answer is 0 for the first one. The only way it's going to be 0 is when x is 0. And in this particular case, 20 subtract a number to be 0 has to be 20. And so the vertex halfway between these two is going to be the vertex. Remember that? So the vertex of x, or xv, the x value of the vertex, is 10. And now I sub this into the original equation. So if I sub x equals 10, because that's the x value of the vertex, into y equals x times 20 minus x. And so I get y equals 10 times 20 minus 10. And I get y equals 10, and 20 minus 10 is 10, and so y equals 100. And so my vertex works out to be 10, 100. And once I have my vertex of my equation, I'm now able to answer it. It says find the two numbers that have a maximum product and add to 20. So the answer is, what are the two numbers? Well, they are going to be 10 times 10. Go back to your original question. And the maximum product will be 100. So I can make a concluding statement. I can say, therefore, the two numbers, because that's what the question asks, two numbers are 10 times 10 for a maximum product of 100. And that is the end of your question. Now, sometimes the question's worded a little different and says find the maximum product of two numbers that add to 20. So it just, then they're really looking for the maximum product of 100. I gave that answer in my thing, and so if you answer it the way I have with my therefore statement, you're always going to be safe because you've done it both ways. Okay? Let's move on and do a maximum area question. Okay. Question number 2, maximum area. And these are some people's favorites. They really like these kind of questions, some teachers. And so you see them a lot for grade 10 math, okay? And it seems to be a popular part of it. Okay, so Gianna wants to build a fence or a pen for her new dog. She has 60 meters of fencing material, including a gate. What is the largest possible rectangular shaped pen she can build for her dog? And what will the area of this pen be? So she wanted to know the dimensions, okay, that will make the biggest pen for her dog. Yeah, she wants her dog to have the most amount of space, okay? So think about it. It's always a good idea to draw a diagram, okay? And so I'm going to draw a diagram in this case like this. Let's pretend we have a rectangular shaped pen. And so what I'm going to do is I'm going to say one of the sides is going to be X. Okay, let's say this side is X. So then I'm going to say let one side of the pen be X meters. Okay. Then I have to determine the other side. Now let's pretend we had 60 meters of pen all the way around. Well, if we went all the way around with 60 meters, how far would it be to go just halfway around? Well, most kids can quickly see that that would be 30 meters, okay? If you're going to go all the way around and be 60 meters, halfway around has to be 30 meters. And so we can determine the length of the other side to be 30 minus this X side. So whatever we chose here, say we chose 10 here, then this side would have to be 20. If we chose this side to be, 8 meters, then this side would have to be 22 meters, and so forth, okay? And that would give us our other side. And so I often say, then the other side is 30 minus X meters, okay? And that gives us our two sides. Now, you know that the area is always going to be the length times the width, okay? So if this is the width and that's the length, we have to multiply them to find the area. And in this case, we're going to call the area y. It's just something we do, okay? So let the area be y, okay? And therefore, we can go and say y equals x times 30 minus x. So this is like our width and this is like our length, okay? And since area equals length times width, we're just changing the area to be y, the length to be actually 30 minus x, and the width to be x, and we're multiplying them together. It's not a big deal. And once again, we have an equation that looks a lot like the equation up above, right? Where we had x and 20 minus x. This time it's 30 minus x. So we're in that very, very similar territory, I say to kids, right? It's not that unusual. And I can multiply this out and I can show you how this becomes 30x, okay, minus x squared, which if we wanted to, we could write it as x squared minus x squared plus 30x. And therefore, that minus x squared tells me that my equation is going to open like this, and I'm going to have a maximum value. And what I want to do is find my vertex, which is going to be an x value and a y value. And the x value is going to tell me when it occurs, and the y value is going to tell me the maximum that it ever reaches, because that's what all parabolas do. They have like either a maximum or a minimum. In this particular case, it will be a maximum. Now, I go back to my original equation that I created right up here, and I say roots, okay? What are the roots? And by the way, this part here you don't have to do. This is just me doing some explanation, okay? So what are my roots? Well, once again, when is this 0 and when is this 0? Well, it's pretty simple. 0 is going to occur when x equals 0 and y equals 30. So those are my two roots, okay? And if I'm trying to find my vertex, my x value of my vertex is halfway between my two roots. Well, what are my two roots? Well, 0 and 30. What's halfway between 0 and 30? I hope you don't have to get a calculator out to do that, but you might. It's 15, okay? And so I now have half of my vertex, and I have to find the other half of my vertex. So I sub my x value, x equals 15, into my original equation, and I write this out, okay? I write it out, x times 30 minus x. And so I'm going to put 15 into that equation. So I get y equals 15 times 30 minus 15. And this gives me y equals 15 times 15. Now, some of you may know 15 times 15 in your head. Probably most of you are going to go to your calculator. I happen to know these numbers because I don't know, I'm weird, right? So the answer here is 225. And if you don't believe me, just grab your calculator and just type that in for a second and double check, okay? Now, that gives me the other half of my vertex of 200. Whoops, let me fix that. Made a mistake. I was going to write 255 instead of 225. Erase a couple other spots down here, clean up my page. And 225, okay? And so now I can do my whole therefore statement, okay? Therefore, the maximum area, the maximum area of the pen is 225 meters squared, and it occurs when the sides are, and to get these numbers, look at your question here. What were the two numbers we multiplied to get 225? Are 15 meters by 15 meters. Okay. Notice that in my concluding statement, I include my units. It's really important that I do that, okay? So if that had been feet up here, you'd use feet. If it's meters, I use meters up here, okay? And that ends my kind of question here on maximum area. All right. Kids really struggle with these, but they all basically work out the exact same way. So try not to get too nervous about them. Follow this kind of ideology through. Watch the video over as you do a question. It'll really help you get through a couple of these. And once you've been through it once or twice, you'll find it gets easier and easier to do. Okay, practice makes perfect. Okay, this one is by far the most difficult question, and we get these questions all the time. They're kind of what we call projectile or trajectory questions. They're questions about, when an object is shot up in the air and takes off on us, and what do we do with it? So, the very common, the ball goes through the air, or in this case, it's a ball, but it could be a spear, an arrow, a rocket, just about anything that we want to. And so we have this projectile, something that gets shot. And so I made this question up based on the Toronto Blue Jays and Josh Donaldson. And Josh Donaldson no longer plays for the Blue Jays, but this is still a very valid question. I might have to change that to Vladimir Guerrero Jr., although in a few years he probably won't play for the Jays anyway. So Donaldson hits a baseball on a path indicated by the following equation. And so we have this wonderful equation here, and it looks really complicated, but it's really not that simple. But what you'll notice is that right away is that I have an x squared term and I have an x term. So it's not in vertex form. I would have been really nice if I had just said, oh, here it is in vertex form. And I could do that. I could give you that equation in vertex form, okay? But I'm going to be honest, it kind of make the question a little too easy, okay? So what we have to do is we have to factor this, and we have to factor it. It's not that difficult to factor. What we do is we factor out this number that is in front of the x as well as one of the x's, because there's an x in each one. So let me show you how I do that, and this will help you get to it. Oh, by the way, we can read the rest of the question. It says where x is the horizontal distance, so that's the distance the ball is going to travel, is x, okay? And y is the height, so this is the height, okay? This is the, oh boy, again, here we go. Keep bumping it in the wrong place, okay? So this is your height going up, and this is your distance. The ball is traveling this way, okay? Sometimes these equations actually have time here as opposed to distance, but that's not the case in this one. Okay, so x is the horizontal distance the ball travels in feet, and y is the height the ball is in feet. Draw a graph to represent the flight of the ball, and what is the maximum height the ball reaches and the total horizontal distance the ball travels, okay? And then we even ask a better question is if you had to hit the ball 410 feet to get a home run, did Josh hit a home run? So we, of course, want to be able to determine if, in fact, Donaldson actually hit a home run. So in order to graph it, what I want to get is I want to get the roots and I want to get the vertex. And once I have the roots and vertex, I'm good to go. I could somehow try to figure out the step value using this, but it would be pretty ridiculous, okay? So what I'm going to do is rewrite my question here, y equals minus 0.002469 x squared plus 1.1111x, okay? Now, I'm going to factor out this number here, minus 0.002469 and an x. And I'm going to do that by dividing both terms by this value, 0.002469x, okay? And when I do that, what you're going to see happens is I write the equation with the minus 0.002469x out front, and then I put a bracket, and I end up with x minus a value here, okay? And that x minus a value is really important. And I get that value by dividing these two numbers. Now I'm going to actually do that on my calculator, okay? Because I think it helps students to see this here. I'll just move the calculator up over to this side. Okay, so I take 1.1111, and it's important that you write all the decimals that I give you. And I'm going to divide it by 0.002469, and I'm going to make it minus, and I say equals. And look at that. Now it's pretty small there, but you can see this comes out as minus 450. So it's minus 450. There's a few decimal places after that, but let's be honest, 450 is really what I'm looking for. And this is really important because now when I want to do my roots for this particular question, okay, remember the roots are where it crosses the x-axis. This is really crucial. I'm going to look at this and say, what are my roots? Well, my roots are going to be when this becomes 0 and this becomes 0. And those are going to be 0 and guess what? 450. 0 times anything is going to give me 0. So 0 times this weird number is 0. And 0 times this number, 450, subtract 450 is going to give me 0. And so this is my roots. Okay, now I'm gonna jump down and I'm gonna start graphing my equation for a minute, okay? And just because I think it's useful for me to do this. Now, I have to cheat a tiny bit here, okay? So I'm going to erase this. You guys have the advantage of using a ruler. I can't use my ruler very easily on my screen, so I'm going to insert a couple shapes. The first shape I'm going to do is I'm going to put a couple lines in here. Okay, so I'm going to draw this line in here to give me my y-axis. I'm going to change the color to doesn't let me change the color to black is easy because somehow I've pinned this off. So if I format my shape, fill color over here, I'm going to make it black, and maybe I'll even increase it to 1 point, okay? And now that can be closed off, and I'm back to here, okay? I'm going to make this just a tiny bit smaller. I'm going to repeat this again and do the x-axis the same way, okay? So I'm going to draw it along here. And there comes my black line. That's good enough for me, right? Gets my X and Y axis. And usually when we're doing a graph like this on a trajectory, almost always it's going to start from 0, 0. I don't usually give you a question that's not going to start there. So one of the roots is going to be 0 and the other root is going to be some number. And so what we want to do is we want to determine how can I make this go along here. This, by the way, is distance. Okay, so I'm going to put my pen back on here. See if I can get my pen. What? Uh-oh. Word didn't like something. Let's hope this comes back, because that would be very sad. Word is not responding. Oh, here we go. Thank you. Thank you, Word, for coming back. Okay, so this is going to be my distance that Donaldson hit the ball, and it's in feet. Okay, so I often write it in feet. And then I'm going to count this out. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, and I got 25, 26 spaces here. So this is what I got to do is decide how can I make it so that 450 will fit across, because I know that Donaldson, the roots of this are 0 and 450. And so the ball is going to be hit like this. I think we understand that trajectory is going to look something like that. And so I'm going to go 1, 2, 3, 4, 5, and I'm going to say this is 100 feet. 1, 2, 3, 4, 5, that's 200 feet. 1, 2, 3, 4, 5, and this is 300 feet. 1, 2, 3, 4, 5, and this is 400 feet. 1, 2, 3, 4, 5, and this is 500 feet. So 450 is going to hit right there. It's halfway between. So I know that this ball is going to go something like this and up and back down. And I've basically done that, but I don't know how high it's going to reach. I want to know how high the ball is going to reach, okay? So I need to find my vertex to do that, okay? And I know this much. I know if I look at my roots that the vertex, it's going to reach its maximum halfway between. Well, what's halfway between this? Well, halfway, x would equal 225, okay? So now what I'm going to do is I'm going to sub x equals 225 into my original equation that was given to me, which is y equals this big long equation, minus 0.00249, sorry, x squared plus 1.1111x. Okay, so what's this going to look like? Well, it gets pretty long. It equals y equals minus 0.002469 times 225 squared plus 1.1111 times 225. Okay, because 225 is the value of the x when it reaches its highest point. That's in the middle. It's halfway between 0 and 450. Okay, so now this is going to be a little tougher, so you're going to have to get your calculator out and do some mathematics. So I'm gonna do this in two parts. I'm going to go like this. I'm going to bring this math calculator back over to this side. I'm going to clear this, and I'm going to go 0.00249, right? I'm going to make that a minus number. I'm going to say that's times 225 times 225. What does that equal? Well, that equals minus 125, I believe that was. I lost my calculator, but I'll double check. I'm going to call that minus 125. We're going to round off to the nearest foot here because it's not going to be that big a deal. And then I'm going to go with 125. Sorry, let's just get cleaned up here. I find sometimes when I take a little more time like this, you guys like this anyway when you're in class. So minus 125. And then I have to do this multiplication over here, 1.111, right, times 225. So I go 1.1111 times 225. And what do I get for an answer? Oh, I get 250. Oh, geez. There we go again, jumping all over on me. Plus 250. So in the end, this works out if you add those two together to 125. And so my vertex is going to be 225 on the x, halfway between 0 and 450, and 125 on the y. And this allows me to sort of graph my equation. Okay, so sorry, I just got it's a little jumpy when I'm running this program, and the screen jumps around a little bit on me, as you've noticed. Okay, so first I'll erase that lovely 2 in the middle of my graph. Maybe this down here could be erased. And then I'm going to have to decide how to plot my values on here. So instead of just doing 1, I'm going to do maybe 10, 20, 30, 40. No, that's not going to work. So I'm just going to say this is 10. I'm going to write 20 here, 40 here, 60 here, 70, 80 here. I don't write every one on, as you can see. And that takes me to 120 there, and this will be 140 at the top. And this, of course, is the height of the ball, okay? And it also is in feet, okay? And you should write those on there. It's a little harder for me to write on my side. You can turn your page on the side a little easier than I can turn my screen. And so 125 is the height. And so remember, my vertex is 225. So there's 220, and 225 is about here, and I have to go up to 125. Well, that's 130, that's 120, so it's right in here. Okay, now sometimes it's worth labeling this particular vertex, okay? So it's 225, comma, 125, okay? And now I'm able to graph this. I'm going to make that a little bigger again, and I can just sort of go, ooh, the ball's going to go up like this, and it's going to come back down right there, and it's going to land there. Now, it's not the perfect graph, but it gives you a general sense of what's going on. And obviously, I have to label this as this is the path of baseball. You can name it whatever you want, right? In this case, it's the path of the baseball. So we have to go back and say, well, we have to answer the question. What did the question ask us, right? We graphed it because it did ask us to do that, right? It said right at the very beginning, I believe. No, it doesn't. It says here, what what if what's the maximum height the ball reaches and the total horizontal distance the ball travels? That seems to be typed in there wrong. I'll have to correct that. But so what's the maximum height the ball reaches and the total horizontal distance? And then did he actually hit a home run? Well, we can see this. What's the height the ball reached? Well, the ball reached a maximum height of 125 feet, and it traveled 450 feet, which was long enough to be a home run. So yes, he did. So I need a little more room. So I got some room on this next page. So I'd write, therefore, the ball reached a maximum height of 125 feet. This is important for when they're building stadiums that are indoors. They have to know how far or how high will these guys hit balls, and they do hit the balls. About 125, 200 feet would be really high for a pop fly, but it does happen, and they have to make sure the stadiums are built that high. And it traveled 450 feet, which would be a home run. Okay. And so that answers all the questions. All right. You will get questions on trajectory, and they're all handled roughly in the same way. You'll get questions on maximum area, again, all handled the same way. And you will get questions on the product of two numbers and maximum value of that product. So please use this video again if you need to, and review it. Each of the questions are dealt with. All right, good luck with your homework, and I know this is a tough one, but just do the best you can.